They're doubling about half as fast in outer space as they double underground. So they grow slower. And that's presumably because on the ground, anytime you have even a very small thermal gradient, that causes convection. So the warm fluid rises, the cold fluid sinks, and there's a little bit of stirring. We don't intentionally stir these, but there's a little bit of fluid movement.
And there's no flow for the nutrition. The solution is...
There's an initial flow to start the process, but the flow is done right here at the time. So there's no continuous flow.
There's no continuous.
And the plateau, in fact, the stationary phase occurs when the organisms have exhausted all the sugar in the nutrient medium, and then they stop doubling. And actually, we watched this for a while. The fluorescence stayed up for quite some time and eventually went off. And then in one of them, we had, like, 3 weeks later, a big spike in fluorescence. And one of the biologists theorized that it might have been the cells spontaneously lysing, because some of the fluorescent proteins are partially quenched inside the cells. You let them out, and their quantum efficiency actually goes up. We're not sure, but the main thing was to see that they're growing and metabolizing about twice as fast on the ground as in space. So not a big surprise, but this was really a demonstration that we could measure these kinds of things. Okay, Pharmasat was a drug effect satellite, as the name suggests, and looking at the susceptibility of Saccharomyces cerevisiae to an antifungal drug, voriconazole, if you know antifungal drugs. And this is, again, an optical measurement using LEDs. I'll show you the optical setup a little bit later. And a viability dye that changes color from blue to pink. So this helps us track the metabolism a little more accurately. We have more wells in this one now. There are 48 fluidic wells in 4 rows. And each row gives us a different concentration of the antifungal, and the 4th row is a control with no antifungal. So this way we get a dozen wells of each.